Hello, 8th grade science students. Today we're going to talk about ions. We have spent a little bit of time on covalent compounds and covalent bonding and how that's the sharing of electrons. Ions are sort of the opposite of that. So instead of sharing electrons, they're going to have to trade them back and forth in order to become stable. So what is an ion? An ion is an atom that has gained or lost electrons and therefore has a net charge. We've talked a little bit about this when you guys did the atom diagram PhET simulation. If something gains electrons, it gains negative items, it becomes a negative, it becomes negatively charged. If something loses electrons, it becomes positive because it's lost some negative charges. Let's look at a couple of examples. First one is sodium. So once again, since really this is the basis of everything is those Lewis dot diagrams, if we look at sodium, it's in the first column, so it only has one valence electron. So far we haven't dealt with these very much. If sodium were to become stable, it would have to somehow have 7 electrons shared with it. That's very, very unlikely. Instead, what happens is we lose that 1 electron. Now it's stable, it only has to have now it has no electrons in that valence shell, so the previous shell is full. So since it's lost an electron, that means we can draw it like this. We usually put it in little brackets, and then we can put the charge on the outside. So since it's lost 1 negative item, it now is positively charged. You can think of it this way, that now it has 1 more proton than it has electrons. Let's look at another example. Oxygen. A little bit different. So oxygen has 6 valence electrons. Also has 8 total protons. In order for oxygen to become stable, it could lose 6 electrons, but that's very unlikely. Instead, it's going to gain 2 electrons. So we can say it's going to gain 2 E minus. We now have an Lewis dot diagram that looks like this. It's completely full. So at this point, we're not talking about where those electrons are coming from. We're just talking about the ions. Now, oxygen has 2 electrons in the first shell, plus now 8. So it has 10 electrons and only 8 protons. That means it has 10 negative charges and 8 positive charges. And when we reconcile those, that means its overall charge is 2 minus. And this is also an ion. So an ion is an atom that has gained or lost electrons. In this case, it's lost electrons. In this case, it's gained, and therefore has a net charge. If you lose electrons, you're positive. If you gain electrons, you're negative. Okay, so now we need to look at a little bit more specific information about this, add in a little bit more vocabulary. So generally speaking, there are 2 types of ions, and those are cations and anions. Cations, you can think of it as a cathode. Some people like to think of it as cats are good things, so it's positive. Some people use the T in cat to look like a plus to remind them that it's positive. Cations are positively charged ions. So in our previous example, sodium was the cation. Anions are negatively charged ions. That would be kind of like oxygen. Let's look at 2 more examples. So first one is magnesium. Magnesium is in the second column. So its electron structure looks like this. It's got 2. So it could gain 6 electrons to become stable, but it's much easier to lose 2 electrons. Since it's lost 2 negative things, it's going to be positive. So this one is our cation. And another quick example is chlorine. Chlorine is in the halogen column, which means it has 1, 2, 3, 4, 5, 6, 7 electrons. It only needs to gain 1. That means once it gains 1 electron, it has a full octet and now has a charge of 1 minus. You could also just put 1 negative sign there and that would be fine. Now, there are a couple trends that are starting to appear here. So let's take a look at the periodic table. And for the first time in a little while, I'm going to ask you to take out that periodic table and add some labels to it. So chlorine, and just to clarify before we move on, cation, anion. And there's going to be some trends for those when we look at your periodic table. So here's my periodic table. I've labeled most of the things that you guys have labeled so far. We have the electrons per shell on the side. I've got some of the groups labeled. I have the valence electrons labeled at the bottom, and that's very small. I'm going to label the charges at the top. The reason for that is because I don't want to confuse them with the valence electrons. You may or may not have space there depending upon how you've labeled them. I don't have the columns labeled because that kind of adds some clutter to my diagram. So here's the ion charge. I'm going to label that in red. The first column, all the ones in the first column have one electron in their Lewis dot diagram. That means they're all going to just lose that one electron and become stable, which means these ions are going to have a charge of 1+. Second column, they have 2 electrons in their valence shell. Much easier to lose 2 than to gain 6. So since they lose 2 electrons, like magnesium in our example, they're 2+. The transition metals are a little more complicated. They have a few different electron shells and orbitals, and therefore we're going to kind of skip those for now until we understand those kind of our main 8 columns. The transition metals are something you'll learn about a little bit more when you get to high school chemistry. Our third column, these have 3 valence electrons. It's still easier to lose 3 than to gain 5, and therefore there's going to be 3+. So the trend you're going to see is most of the ones to the left side over here are metals. They have positive charges, they're cations. The nonmetals, once we get further to the right side, are more likely to be anions because they're going to gain electrons. This column is the most complicated, so they have 4 valence electrons. It's approximately as easy to gain 4 electrons as it is to lose 4 electrons, so we actually have to say 4 plus or minus. So if carbon were to gain 4 electrons, it would be 4 negative. If it were to lose 4 electrons, it would be 4 positive. Most of the time, carbon is doing covalent bonding anyway. However, good to keep in mind. Next column, now they've got 5 valence electrons. Much easier to gain 3 than to lose 5. So in this case, since they're gaining 3, they're going to be 3 negative. Next one, 6 valence electrons. We're starting to get the pattern. Easier to gain 2 than it is to lose 6. And therefore, it will be 2 negative. And our halogens, our final column for this, has 7 electrons. Much easier to gain 1 to have a full octet than to lose 7, and therefore their charge will be 1-. The reason why I'm not putting a charge on this column is because those are our noble gases. They already have full octets, and they do not need to gain or lose electrons to be stable. They already are. Okay, hopefully you've had a good opportunity to label your periodic table. Next week, or the next set of assignments, we hope to do a little bit of practice with this and start talking about what an ionic bond is. Have a fantastic day.